Hello? Hello!
Hi.
My name is Dr. Lawrence Turtleman. I'm a professor of turtle studies and have several different areas of expertise, but the Green Brothers decided today that they would invite me out to a book launch event to discuss phylogeny and taxonomy, which is what I tend to do lectures on. I don't know why. Seems like a weird decision, but I was happy to indulge them. So, let's go to the next slide, please. I know that we all sometimes lay awake at night and we think to ourselves, hey, phylogeny and taxonomy. I know that those two things are related. But what exactly is the difference between those two things? And you can't sleep. That's all you can think about. So I decided I would answer that question. Next slide, please. What do you want? Phylogeny, also called phylogenetics. We understand what the second half of that word means. Genetics. It's all the information that's coded inside of our DNA. It tells ourselves how to build themselves and thus how to build our whole bodies. And philo actually comes from the same root as the word phile, which is why I put a filing cabinet on this side. It's basically a genetic philo. It's categorization based on our understanding of our DNA and our genetics. I'm going to try really hard not to fall off this stage. Make me nervous. Go back over here. All right. Turtles don't have great depth perception. Next slide, please. Taxonomy, on the other hand, was created 100 years before Charles Darwin was even born. The father of modern taxonomy, Carl Linnaeus, was an amazing guy who figured out a huge array of how we could classify organisms based on their body forms, based on things that they had in common physiologically. And taxonomy allowed us to have a much greater understanding of how organisms were related to each other back before we even understood that organisms were related to each other, before we understood evolution, before we understood genetics. Carl Linnaeus, everybody. Pretty great. Carl Linnaeus, 100 years before Darwin was even born, was creating these things called taxa. These are categories that we place animals in to understand how they are categorized and how they are related to each other. And you've seen these before. We're still using them. Domain, kingdom, phylum, class, order, family, genus, and species. And you learn about these in biology class and then forget them so that you have to turn around and look at the slide even though you do this for a living. It's okay. So each one of these taxa has taxa below it, except for species, which kind of has a taxa below it, which is subspecies. So sometimes a species has multiple subspecies. Next slide, please. A monotypic taxa is any taxa that has only one category in the taxa below. And so a monotypic species would be a species with only one species, and thus no subspecies, like the indigo macaw. Also, like all of you in this room, Homo sapiens. Also, like Turtleman, we're also a monotypic species. But you could also have a monotypic genus, which would be a genus with only one species and no subspecies. Next slide, please. For example, the chocolate chip star, Nidorellia armata. It is the only species in the genus Nidorellia. That's all I know about it. It's cool looking. Next slide, please. But could you have a family that only has one genus, that only has one species? Now we're starting to get pretty rare here. So all of these categories exist so that we can categorize these organisms as we move up this chart here. It's getting weirder and weirder to see that there's only one species in a single taxa. And this does indeed happen. Next slide, please. The bearded reedling, Panurus biarmicus. It's a bird. That's all I know about it. Next slide, please. But could you have something even weirder? An order that only has one family, that only has one genus, that only has one species? Next slide, please. Yes! In terms of terrestrial vertebrates, there are 3 that I could find. There might be more, but no one has told me I'm wrong, so I'm pretty sure I'm right. Next slide, please. This is order Turtleman type. It contains one species, the aardvark. Now you might be thinking to yourself, wait, Dr. Turtleman, I've seen South American anteaters that look just like this. But in fact, South American anteaters and the aardvark are not related at all. The aardvark roams all across Central Africa and is an extremely effective and successful species. But despite that, all of its closest relatives have gone extinct. In fact, next slide please, this is one of its nearest living relatives. Right? I included it mostly because it's cute. But also, the elephant shrew, which when Europeans first found elephant shrews, they said, wow, that looks like a shrew that kind of looks like a little baby elephant. It's got a little elephant trunk, so it's obviously a shrew that looks like an elephant. We'll call it the elephant shrew. But in fact, the elephant shrew is more closely related to elephants than it is to shrews. That's just a real fact. I mean, you might have thought 5 minutes ago, what's the big gonna be? Nope. It's just a presentation on monotypic cats. Next we have order Pistaconiformes, which includes one species, the Watson. The Watson branched off from other birds about 64 million years ago. It's okay, she's spelling out Watson real fast. H-O-A-T-Z-I-N. It's a weird bird. Look at it. I mean, really? Its nearest common ancestor with other birds existed around the time that dinosaurs went extinct. It's barely a bird at all. And it also has a really weird way of surviving. The Watson, unlike almost any other bird I can think of, actually eats leaves off of trees. It's a ruminant, basically. It's like a flying cow. It has bacteria in its guts that dissolve cellulose and turn it into sugar so that it can survive on the feeding leaves. And because of that, it poops a whole lot, which is why in South America they're called the stink bird. Next slide, please. And finally, we have order Rhynchocephalia, which contains one species, the tuatara. They're very popular. The tuatara look a lot like lizards, right? But in fact, they are very, very separate from lizards. They branched off from lizards a very long time ago, and in fact, tuatara are about as closely related to lizards as birds are to crocodiles. That's a huge separation in terms of both genetics and time. And tuatara are not as effective at living as like modern lizards and snakes, because those animals have had more time to figure out how to be effective animals. And so, when new species started to be introduced to New Zealand, where order Rhynchocephalia was able to persist for a very long time, they started to go extinct due to habitat infringement and also other species outcompeting them. But luckily, New Zealand, which is very far removed from everything and sort of had that island effect of allowing Rhynchocephalia to survive, has on the edges of it other little New Zealands that are like, I'm New Zealand, but also a little bit over here. And that allowed the tuatara to survive on those outlying islands of New Zealand, where they survived, but then were able to be taken from there and reintroduced to New Zealand. And now we can study them and learn all kinds of things about the evolutionary history of snakes and lizards, but also of how evolution works and how genetics works. The tuatara are very weird, and we're learning a lot from them. So I'm very glad that they didn't go extinct yet. And I say yet because everything will someday go extinct. It's okay. Someday, the Earth will be consumed by the sun. Next slide, please. When we talk about phylogenetics, when we think phylogenetically, that's when we say things like, the dinosaurs never went extinct, they just became birds. Because phylogenetically, everything is what it once was. Which means that you are a mammalian, amniotic, tetrapodal, sarcopterygian, osteichthyan, gnathostomal, vertebrate cranial chordate. And that's an interesting thing to be. Especially because this one right here, osteichthyan, it means bony fish. Because you are what you once were. And so, I stand here in front of a room of bony fishes. And even I, a turtleman, because I am also a terrestrial vertebrate, am a bony fish. All terrestrial vertebrates were descended from the bony fishes. And that's a remarkable way to think about things. It allows us to understand that not only are all Homo sapiens one family, but also all organisms on the Earth are sharing this process of becoming living organisms and evolving toward a more effective and harmonious future together, which is a lovely way to think about things. And I encourage all of us to occasionally, probably not all the time, but occasionally think phylogenetically. Thank you very much to the Green Brothers for having me out. My name is Dr. Larry Turtleman. I'm available to do speaking gigs all over the nation. I'm very low priced. My website is at drlarryturtleman.com. Thank you.